Hi, let's take a look at an example of a relativistic Doppler shift question, and in a silly way sort of ask, can relativity help you argue your way out of running a red light? Now, with the Doppler shift, all waves appear to change their wavelength and appear to change their wave frequency whenever there's relative motion between a source and an observer. So most traffic lights are stationary, so whatever velocity that you have towards or away from that traffic light can shift the wavelength of the light that you see and therefore shift the color of the light. So say that the red light normally has an average wavelength of about 630 nanometers, and the green light has an average wavelength of about 540 nanometers. If you were to travel at the right speed fast enough either towards or away from the red light, then you would see that color shift from red to green. Now, if the relative motion is towards, we call that type of shift in astronomy a blue shift, because blue is the higher end of the wavelength spectrum in light, or higher end of the frequency spectrum, which would be the shortest wavelengths when it comes to light. And if we're moving away, things shift towards the red end of the spectrum, which is what we call a red shift. So going from red to green, that means we would expect our relative motion to be towards. So physically it's plausible that if you're headed towards a stoplight, you would be able to perceive the red as green. Now, it won't argue your way out of the fact that it would be a green light at the top of the signal, not at the bottom of the signal, and the green light would be a blue light, but that's a totally separate argument. So, say we want to calculate the speed, knowing our wavelengths. Well, the relativistically correct way of doing a Doppler shift for wavelength is to say that our shifted wavelength is equal to the wavelength being produced when there's no relative motion times the square root of 1 minus the relative velocity over the speed of light divided by 1 plus the relative velocity over the speed of light. And we need to solve for that relative velocity. So what I'm going to do is I'm going to start by taking both sides and dividing by my unshifted wavelength lambda. And then just to avoid writing a lot more terms in my algebra, I'm going to define a symbol capital lambda equals little lambda prime over lambda, and I'm going to define beta to be equal to V over C, which we commonly use in relativity. So that would mean that what I have here is the square root of 1 minus beta over 1 plus beta is equal to capital lambda. So I can square both sides and then multiply to get rid of my denominator, and that would give me 1 minus beta is equal to capital lambda squared plus beta times capital lambda squared, multiplying both sides by 1 plus beta. So I need to solve for beta, get all of my beta terms to one side. Since that's minus beta over there, I'm going to add it to the other side. So I would have beta plus beta times capital lambda squared. I'll subtract my capital lambda squared over here. So that'll equal 1 minus capital lambda squared. And then I can factor out my beta and divide both sides by the quantity 1 plus capital lambda squared to find out that my relative velocity is going to be 1 minus my ratio of wavelengths squared divided by 1 plus my ratio of wavelengths squared. Now I said that capital lambda was the shifted wavelength divided by the unshifted wavelength. So our shifted wavelength is green, so we'd have 540 nanometers. Our unshifted wavelength is red, we have 630 nanometers. And when I divide those together, square them, and subtract them from 1, I get a value of 0.2653. And then when I add that same value to 1 in the denominator, I get 1.7347. So if I divide those two pieces, I get a relative velocity, v over c, equal to 0.153. So if you could reach 15.3% of the speed of light, red light would look green to you. However, that speed would be 46 million meters per second, which would be about 103 million miles per hour. And depending on the jurisdiction, you would be pleading guilty to an incredible speeding penalty. And for the Commonwealth of Pennsylvania, speeding penalties charge you $2 per mile per hour over 5 miles over the posted speed limit, plus a little bit extra, which when you're talking millions of dollars, doesn't really matter. So you'd be looking at about a $205 million speeding ticket instead of a ticket for running a red light. So you could make the argument, but you could be out a lot of money doing so. Thanks for watching.